Alright, so example 4, almost. First, what I want you to do is go ahead and pause the video and copy down these steps for implicit differentiation. So, based off the previous examples, we've done a couple of things. The first thing is we differentiated both sides with respect to x. So we took the derivative of both sides. The second thing that we did every time is that we collected the terms with dy dx or y prime on one side of the equation. So anything that had dy dx we put to one side, everything else we put to the other. Then the next key is to factor out dy dx. This is to isolate or solve for dy dx. So you factor out the common term dy dx, which was resulted from when you moved everything with a dy dx to one side, and then you solve for it by dividing by what's left after you factor it out. These are the 4 steps you're going to be using to do implicit differentiation, and it's called implicit because we end up with x's and other variables in our answer. Okay, so once you have this copied down, go ahead and hit play again. Alright, now that we've got that all copied down, let's move on to example number 4. Example number 4 says to determine the tangent and normal lines to the ellipse x squared minus xy plus y squared equals 7 at negative 1 comma 2. So if you don't remember what an ellipse is, it's basically a circle that's either been stretched or smushed. What I mean by that, it's an oval. So let's just take a look real quick at what that relation looks like. Right there's an ellipse. I'll make it a little bit bigger so we can all see it, and we'll lightly shade it in just for fun. Let's make it some weird color, like, I don't know, that color. So now we've got an ellipse. I colored it in for fun. Again, it was a circle and we smushed it. Alright, so on to the next thing. Where is it? Oh, there's one up. Alright, so step 1. What does step 1 again say to do? It says to differentiate both sides with respect to x. So let's do that. Step 1. Differentiate, and I'm just going to abbreviate diff both sides with respect to x. So d dx. Alright. So we're going to get d dx x squared minus xy plus y squared equals d dx of 7. Okay. This is where this is going to get a little complicated, but that's alright. We're big kids in calculus. So I'm going to take the derivative of each piece. So here we go. The derivative of x squared, easy, 2x. Now this is where you need to be very careful. These are 2 different variables being multiplied together. Again, they're being multiplied. This means we need to use the product rule. Okay. So the product rule says that you take the derivative of the first times the second plus the first times the derivative of the second. So what I'm going to do is I'm going to throw that negative out in front and put a big pair of brackets. So the derivative of the first term, the derivative of x, is simply 1. But I'm going to break it down just step by step. The derivative of the first times the second plus the first times the derivative of the second. And just to make this more clear, we're taking the derivative here and here. Okay. Then plus the derivative of y squared. The reason I'm writing like this is a lot of times students will forget to write the d dx and then they'll just put 2y, and that's not the correct answer. And the derivative of 7 is simply just 0. Okay? So here we go. You get 2x minus the derivative of x is 1, so you get 1y plus x times the derivative of y plus, now again, here's the chain rule. It's 2y times the derivative of y. This equals 0. Okay, so I'm going to go ahead and get rid of my parentheses now. 2x minus y plus x dy dx plus 2y dy dx equals 0. Okay. Now we need to get all of our terms with dy dx to one side and everything else on the other. So I'm going to subtract 2x and I'm going to add y to both sides. If you need to do them one step at a time, that's all right. dy dx plus 2y dy dx is equal to negative 2x plus y. So now what I'm going to go ahead and do, make sure I didn't make a mistake there. Everything looks okay. I'm going to go ahead and factor out that dy dx. I'm going to factor it out, and that's going to leave me with x plus 2y is equal to negative 2x plus y. Okay, I'm just double checking for mistakes. I think everything looks okay here. So now what we're going to do is we're going to go ahead and divide both sides by x plus 2y. I found a mistake. I found it. You go, about 5 steps ago, you're like, Mr. Cooper, you made a mistake. I made one of the oldest mistakes in the books, and here it is. I'm not even going to take it out of my video because it's so important that I point this out. I forgot to distribute my negative. This catches up students so much, and it just caught me. I should have a negative in all these places. Right? My negatives. Do not forget to distribute the negative. I can't believe I forgot it, but it's good that you just saw it happen. Okay. So we're left with dy dx is equal to y minus 2x divided by 2y minus x. Now, the only reason I wrote it like that is just because I like positives in the front. That's the only reason. Okay? So that was step 1. We got dy dx all by itself. That's good. I don't like the way that highlighter looked. All by itself. So this is fantastic. All right. Now for step number 2. And step number 2 is to plug in the point -1, 2 to determine the slope. Right? Because we want a tangent line. And to find a tangent line, we need a slope. So we have dy over dx is equal to 2 times, oops, not 2, just kidding. 2, we're good, 2, minus 2 times -1 divided by 2 times 2 minus a -1. All I did there is wherever I saw the x and the y's, I simply just plugged in the numbers. I substituted in the correct numbers. So we get dy dx is equal to 2 plus 2 divided by 4 plus 1, which comes out to a whopping 4/5. Again, this represents m. This is our slope. We're almost there. We're almost done. We have 2 more steps. Step 3 is to determine the tangent lines. Okay? That step 3 is to determine the tangent lines. Well, remember, it's y minus y1 is equal to m times x minus x1. That's our equation of a line. So we get y minus 2 equals 4/5 times x minus a negative 1. So this is y minus 2 equals 4/5 x plus 1. Y minus 2 is equal to 4/5 x plus 4/5. Y is equal to 4/5 x plus 4/5 plus 2. Y is equal to 4/5 x plus 4/5 plus 10 over 5. And so we get our tangent line is y equals 4/5 x plus 14/5. Okay, and that's the equation of our tangent line, easy as that. And if I look at the graph, which I have right over here, scoot this back over, we can see this represents that decimal. Okay? And right here, this is the tangent line. Okay? Now let's talk about the next one. Step 4. We've almost found everything. The last thing we wanted to do is determine the equation of the normal line. Alright, so to find the equation of a normal line, we just write y minus y1 equals m times x minus x1. Now remember, to find a normal line, you take the slope, you take its reciprocal, and its opposite. So we get y minus 2, instead of 4/5, we get equals negative 5/4 x plus 1. Do a little basic algebra. Negative 5/4 x minus 5/4. Y is equal to negative 5/4 x minus 5/4 plus 8 over 4. And you get y is equal to negative 5/4 x plus 3/4. Boom, 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 boom. Bada bing, bada boom. Let's go check our graph, make sure we're right. Let me go grab it real quick and put it where it belongs. Here we go. And you can see right here, you have a slope of negative 5/4 and the y-intercept of 3/4. So it matches. Okay, and again, remember, the normal is perpendicular to the tangent. If I can zoom in, there we go. The normal line is perpendicular to the tangent line, where this is the tangent and this is the normal. Alright, pretty easy. So now what you need to do is you are going to determine the equations of the tangent and normal lines to the circle x squared plus y squared equals 16 at the point 1, 2. So go ahead, take the time to work this out on your own. Pause the video, and when you're ready, hit play. Alright, so you solved it. You got a tangent line and a normal line. Hopefully you got two equations. We're going to work it out right now together, and we're going to get those lines. So, step 1, differentiate. So I'm going to write x squared plus y, x squared plus y squared equals 16. And I'm going to go ahead and take the derivative of both sides. Oh, my computer's getting hot on my hands. So we take the derivative, and you get 2x plus 2y dy dx. Basically, every single time that you get the derivative of y with respect to x, you're always going to get that dy dx equals 0. Now we got to solve for dy dx. So we get 2y dy dx is equal to 2x, negative 2x. And so you get dy dx is equal to negative x over y. and you get this by dividing 2y to both sides. Okay, that was step 1. See how that can be very quick. Step 2 is to take dy dx and go ahead and plug in the point 1 comma 2. So this is going to be negative 1/2. Again, this is m. This is our slope. So now let's find our tangent line. This is also a good way to organize your work. Label what you're doing. Makes my life much easier. Okay, so we have y minus 2 is equal to negative 1/2 x minus 1. Right? Y minus y1 equals m times x minus x1. Now again, on the AP test, you can stop there. My class, I need you to keep going. Y minus 2 is equal to negative 1/2 x plus 1/2. So y equals negative 1/2 x plus 1/2 plus 2. And if you can do these steps in your head, that's okay. I'm just going to write them out. Make sure everyone knows where everything came from. And we do some algebra, and boom, boom, boom. There's our tangent line. Nice, clean, and easy. Okay, now let's find the normal line. Normal line. So to find the normal line, we do y minus 2 is equal to, now remember, the slope is the negative reciprocal. 2 over 1, x minus 1. Now nobody writes 2 over 1. It's 2x minus 1. Y minus 2 equals 2x minus 2. Y equals 2x plus 0. So y is equal to 2x. There is your normal line. It's as easy as that. It's exactly like we've been doing, just with one tiny little extra step.